Alright, today you're going to start taking a look at story problems. Right? This is the last new thing that we're going to do in this unit. Okay, this is going to finish up our trig stuff. So there's really just kind of two new vocabulary ideas that we need to talk about before we jump into the problems. And that is angle of elevation and angle of depression. Right? So angle of elevation means we're looking up at something. Okay, so if you want to make a little note that that's what that means. Right? Angle of elevation means we are looking up at something. So if I'm told, like, for example, in this problem, the angle of elevation from my line of sight up to the sun is 43 degrees, right? That would be an example of this picture. Right? I'm looking up at the sun, even though you should never look at the sun. Right?
Only when you have sunglasses.
Only when you have sunglasses.
No, I didn't get it.
Right? Angle of depression, then, means I'm looking down on something. Okay? Angle of elevation just means I'm looking up, and angle of depression just means I'm looking down. Hopefully. Okay. So what we're going to do first on this sheet, we're going to look at some problems where they've got the picture sketched for us already. Okay? We're going to go through solving each of these problems. Then we're going to look at some problems where we have to sketch the picture. Right? That's going to be our goal for today. So let's go ahead and take a look at these first two examples here. So in the first one, it says a kite is tethered to the ground with a 100-foot string. What does tethered mean? Tied. Yeah. Right? So the kite is tied to the ground with a 100-foot string. So this string from the ground up to the kite is 100 feet. The angle of elevation, so that means looking up from the ground, is 52 degrees. How high is the kite off the ground? Okay, so this is my triangle here, my right triangle. And my goal is just to solve for this missing side. So what's the first step in any trig problem?
Label the sides.
Label the sides. Okay, so with respect to this angle, is x opposite adjacent or hypotenuse? Opposite. And 100? Hypotenuse. So if I'm dealing with opposite and hypotenuse, what trig function? Sine. So my setup would be sine of what? Sine of 52 equals x over 100, right? Opposite over hypotenuse. So how do I solve that? Multiply both sides by 100. Well, so we already have x by itself now, right? So I can just put this in the calculator.
I got 78.80.
78.80. Now, since this is a story problem, we should include units. So 78.80 what? Well, so yeah, so feet equals x. Right? We're talking about this kite is 78.8 feet off the ground. Right? Okay, so far?
Yep.
All right, so let's take a look at the second one here. This is another angle of elevation problem. So it says the angle of elevation from the ground to the top of a 30-foot tree. So we know the tree is 30 feet tall. This picture. And that angle of elevation is 35 degrees. The question then asks, how long is the tree's shadow? Now, in this picture, we did not label where x should be. So where should x be if my goal is to figure out how long the tree's shadow is? The hypotenuse?
The other one.
The bottom one?
Yeah.
Here, for both answers, which one is it?
The bottom one.
Yeah. Shadow's on the ground, right?
That's what I was thinking in my head. I was like, it's on the ground, man. Put the X there. I need to go.
Alright, so this would be my setup. Right? So with respect to my 35-degree angle is 30 opposite adjacent or hypotenuse. Opposite.
Sorry, guys.
And x adjacent. So what trig function? tangent. Right? So what's my setup? 35 equals 30 over x, right? Opposite over adjacent. So how do I solve that? 30. Right. This is actually a two-step problem, right? We'll multiply both sides by x and then divide by the tangent of 35. And what we end up with is x equals 30 divided by the tangent of 35. Some of you are there already, and I can't write that fast. 42.84? 42.84 what? Feet. Right? Again, in this problem, we're talking about a distance of feet. Yes. All right. Good so far? I mean, the solving part is stuff we've already done. Right? It's just the new part is kind of getting that information of how to set up the triangle from the word problem. All right? Oh, you solved for every single side and angle? Nope, you did more than you had to. Alright, let's jump down and take a look at number 3 then. Alright, on this one, we are told a 25-foot flagpole. So our flagpole here, straight up and down, is 25 feet, casts a 42-foot shadow. So that is on the bottom here, on the ground. My goal is to figure out the angle that the sun hits the flagpole. So they labeled that for us, right? If the sun's coming down and hitting the top of the flagpole, this would be the angle that I'm trying to find. What do I do first? Label. So what do I label? Opposite's the bottom, the 42. Plus, and the 25 would be adjacent, right? So the trig function would be tangent. Right, so tangent of the angles, the angle in this case is x. So tangent of x equals 42 over 25. So now how do I solve this? So
Multiply by the inverse.
So we're going to take the inverse of both sides, right? Whenever I'm solving for an angle, whenever my variable is trapped inside of a trig function, that's when I take the inverse of both sides. Right? And I know it's weird, but we're not actually multiplying both sides, we're taking the inverse of both sides. I know that's kind of a weird thing. Right? But we end up with x equals the inverse tangent of 42 over 25. So what is that? 9.24 what? Degrees, right? In this case, we solved for an angle. So my label would just be degrees. All right, now, this last example on here talks about angle of depression, right? So it says Maria is on a 40-foot tall cliff, right? So this distance here, from the top of the cliff down to the water, is 40 feet, and she sees a seal. The angle of depression, right? So she's looking down at this seal. We're saying that angle of depression is 52 degrees. Now, this is important, right? When I'm saying angle of depression, what I'm looking at is this angle here that's outside of my triangle. Right? The angle of depression is this angle up here. That is my 52 degree angle. We're saying from here, looking down, right? So that is the 52 degree angle. Right? Now, on these problems, we are going to use a geometric property, right, that I'm guessing most of you don't remember, or at least don't remember the name of it. Yeah? So if I've got two parallel lines, right, so my line of sight, if I'm looking straight out, would be parallel to the ground, right? So I can say these are parallel lines, and I cut those parallel lines with this transversal, okay, with my line of sight looking down. I can say that these two angles, the name of the relationship between those two angles? Alternate interior. Right, nice.
Shout out to Miss Marshall.
So if I have a pair of parallel lines cut by a transversal, I can say that alternate interior angles are congruent. Okay? You don't need to know that term. Okay? But what you do need to know is that if this angle is 52 degrees here, this angle inside of my right triangle is also 52 degrees. Okay? So whenever we have an angle of depression problem, and whenever we're talking about looking down on something, this angle outside of the triangle would be my angle of depression. That means that this angle inside of the triangle is the same. Make sure that you don't try to say that this angle is 52 degrees. Okay, that's a common mistake when we're talking about angle of depression. People just want to make this angle up at the top the 52 degree angle. And that's not correct. Okay, so don't fall into that trap. So then to actually do this problem, right, we've got everything labeled. Okay, we've got the 40-foot cliff, the distance from the seal to the cliff, and our 52 degree angle. So what would I do to actually find that distance? Yeah, we're trying to find this distance here.
Can you just use Pythagorean theorem? Or no, never mind.
Yeah, because we don't know this side either.
Right. Dang it.
Well, my goal is to find the length of this side. So finding this other angle isn't really going to do any good. Yeah, so this is going to be tangent, right? Because 40 would be opposite, x would be adjacent. So my trig function that I'm going to use here is tangent. So the tangent of 52 equals 40 over x. Now what? Multiply by x. Alright, divide both sides by a tangent of 52. Those cancel. So what is 40 divided by the tangent of 52? 31.25. 31.25 what? Feet, right? Again, we're talking about a distance in feet. Alright? Yeah. I've got another one. Don't worry.
This is just like there's 10 of us. 10.
11.
See?
Yeah, I'll take a look.
My mom said, "Are you at school?" And I sent her a picture of the math work, and I said, "Yeah, I'm math work." She's like, "Okay." I said, "I mean, I would like to be in it, but I decided to come to school during the mature thing." Yeah.
Good choice.
And then my manager was
Let's see. What's up?
what is your
The whole point of what? Well, because that's how our angle of depression is visually set up. There we go. How so?
Because it makes me feel like there's like an extra but I don't.
Yeah.
It was me though. I was
Alright, so with these problems now, we are just going to draw the picture that models the situation. Okay? We're going to go through all 8 of these and just draw the setup. Right? Then we'll come back and solve. Alright, but first, we're just going to draw the picture for every single one of these things first. So let's go through a few of them together here. Alright, we can we know that all of these are going to be modeled by a right triangle, so we can just start by drawing a right triangle. Yeah, you can draw a right triangle for all of them. Right? So this first one says the angle of elevation of the top of a building from a point 100 feet away is 65 degrees. So what is this angle of elevation? Where is that? Is that this angle or this angle? Which one should be the 65? Right, the bottom one. So that's the one that's looking up at the top of the building. Right? This is angle of elevation, so I'm looking up. Now it says this angle of elevation is from a point 100 feet away from the building. So where should this 100 go? At the bottom, right? If my building's over here, this distance is my 100 feet away from the building. Now my goal is to find the height of the building. So where should my x go?
On the side.
Right, over here. Right now we're just going to set them up. Okay. So, alright. So, we okay with something like that? No.
This is a lot easier than what we just did.
It's less work.
It's not that bad.
Alright, so let's take a look at number 2. Let's take a look at number 2 here. So in number 2, the first piece of information tells us that the Willis Tower is 1,451 feet tall. Where should I put that piece of information? On the left side, right? We're talking about the height of a building, so that's going to go over here. Now it says a person across the street. Right? So here's the building. You can think about the person over here across the street is 30 feet away. So 30 would go on the bottom. And my goal then is to find the angle of elevation from the ground to the top of the tower. So here, I'm finding an angle. I'm not.
Oh, okay.
Yeah. So if we're thinking about A, B, C, our goal would be to find this angle down here, right? The angle of elevation. So, I mean, you can label that with a theta or an x, whichever makes more sense. Right? But in this one, we're trying to find an angle. Okay. You okay with that one? Not yet. We're just going to go through and draw all the pictures first, and then we'll come back and solve them. All right, so now in numbers 3 and 4 here, we're talking about an angle of depression. Right? So in number 3, we've got an airplane flying at a height of 2 miles. Over here? Yeah, so 2 is over here, the height that the airplane is. The distance along the ground from the airplane to an airport is 5 miles. So where should that piece go? Yeah, so the distance along the ground.
So it'd be the bottom.
So it'd be the bottom, right? This would be my 5. Now, it says find the angle of depression. Right? So angle of depression is this angle looking down, right? This would be my theta, right here, outside of the triangle like that. That's what angle of depression means, right? If this is my line of sight, this is like the airplane's flying on this path. So if it's looking down, this outside of the triangle would be the angle of depression. So which angle inside the triangle? This one or this one would be the same. Bottom, right? Okay. So what you have to be careful of on angle of depression problems is understanding that it's not this top angle inside of the triangle that we're solving for, and it's actually this bottom angle, okay? Using that idea of alternate interior angles.
So either way, it's going to be the bottom one.
Yes.
Okay.
Yeah.
Okay.
All right. So You okay on the setup for that one?
Yep.
Alright, let's take a look at 4 then. Okay, so let's draw my right triangle. So, yeah, so 15-foot lamppost, so this would be the height of my lamppost. The angle of depression, so, alright, so 35 degrees there for my angle of depression, meaning which angle in here would be 35? The bottom one. Right, so the distance that the bird must fly to catch the mouse. So if the bird's at the top of the lamppost, the mouse is down here, the bird is going to fly along this path here. So the hypotenuse would be what I want to find. Okay, the distance that the bird would have to fly. Alright. You okay with these?
Wait, go.
Alright, so I want you guys then to try the 4 on the back. Okay, just draw the pictures. We're not solving them yet. Okay? So just go ahead and flip over and draw the pictures.
Oh my god. Wow.
Action. Alright, let's take a few minutes to go over these, make sure that we have the right pictures. Right, so on number 5, a surveyor is trying to figure out the width of a river. Right, so she starts here and walks 150 feet upstream. Right, so this side I can say is 150. She then looks back from this point down to here at a 38-degree angle. Our goal then is to figure out the width of the river. Number 6 then, okay, from the edge of a 35-meter cliff, so the height of my cliff here is 35, Lori spots a hiker at an angle of depression of 62 degrees. So she's looking down at this angle of 62 degrees. That means inside of my triangle, this would be my 62-degree angle. Okay, then our goal is to find the distance the hiker is from the cliff. So my x would be down here on the bottom. Okay. Good so far?
No.
Are you just saying no just to say no? Alright, so then numbers 7 and 8. So on 7, we get a 15-foot ladder. Right, so I'm taking this ladder that's 15 feet, leaning it up against a house. So I think my 15 would be the hypotenuse here. Then it says it forms a 68-degree angle with the ground. So with the ground would be down here. Then my goal is to find how far from the house is the base of the ladder. So my x would be on the bottom here. Then my last one is zip line. It's attached to the top of the building. It has an angle of depression of 24 degrees. The end of the zip line, okay, so down here would be the end of the zip line. It says it's 200 feet away from the building. Our goal then is to find the length of the zip line. So the hypotenuse would be my x here. Right? And then, I guess, if this angle is 24, we also know that this angle here is 24. Questions?